Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos. Hello friends, today we are starting a new topic is named as deflection of beam using geometrical method. In geometrical method there are various methods. The first one is Macaulay's double integration method, and the second one is moment area method, and the third one is conjugate beam method. In that today we are seeing a Macaulay's double integration method. Let's see in details. Now see, this is named as chapter deflection of beam using geometrical method. In that we are seeing Macaulay's method. First of all, I am just explaining you what is the slope and deflection over here. See, take one example over here. See, this is a one rod. This is a just example for better understanding. This is one rod and this is a W. Okay, this elastic curve will be like this. Okay, now see, if the what is nothing but y is nothing but your deflection. See, this is a diagram of symmetrical loading. If you are applying a load of W in symmetrical loading in equal distance, your if the loading is symmetrical, maximum deflection y max always occurs at the center. Means we have to find the deflection part over here. Now this is a deflection part, means this is nothing but our y max at the center. Now our second point will be at the point of y max, slope dy by dx is equal to is always 0. Now when we have to find the slope, we at any point we have to find the slope. What we have to do, we have to just draw the tangent over here. Now we have to find slope over here. Just draw the tangent line over here with respect to this reference line, this A and B. Okay, and this with respect to this line is not making any angle. That's why here dy by dx is equal to 0. Where the deflection is maximum, slope will be 0. And see, if you have to find the slope is always occurs at the corners mostly. This is your slope and this is your slope equation. This is theta and this is also theta. If any point we have to find that slope, what we have to do, we have draw the tangent over here and just take with reference to the angle. If we have any theta or angle, that angle is nothing but your slope, and the deflected part is nothing but is deflection. Okay, now theta is denoted by slope and y is denoted by deflection, or you can write deflection is denoted by y or slope is denoted by theta. Okay, theta is nothing but your slope and y is nothing but your deflection. Now after that, now next topic will be method of slope and deflection. There are various methods of slope and deflection. Just take like some examples. First one is nothing but Macaulays is nothing but your Macaulay's method, and the second one will be moment area method, and the third one is conjugate beam method. Okay, in three of them today we are seeing a first one is nothing but Macaulay's method. Now by using Macaulay's method, you have to find the slope and deflection, which is coming in the exam, whatever he is asking. Okay, now in Macaulay's method we have to remember certain points. Number one will be Now it is a simple method based on the double integration concept. Macaulay's method is also known as a double integration method. Please remember these things. Macaulay's method is also known as the double integration method or concept. Okay. Now second point will be, you have to remember in this method. Now let's see. In this method, bending moment and at any section is expressed in the systematically order. Systematically order means you have to take this systematically one by one. Okay. Now the section X is to be taken in the last portion of the beam. Always take the X. Always take the section X last portion of the beam. All right, left or right. I am explaining in the question also. Okay. Now after that, fourth point we have to remember over here. Now in this method, bending moment due to each forces or UDL is separated by a compartment lines. In Macaulay's method, we use the double integration concept to get the slope and deflection respectively. After that, let's start with the question number 1 of Macaulay's double integration method.